Hello and welcome to Python for Engineers. This is lesson 3. We're going to be discussing the basics of coding in Python. I'm going to start with comments. Comments aren't necessary, but they're incredibly useful, and it's usually a good idea to comment your code. So the first way to do a one-line comment is with the pound symbol. Alternatively, if you want to do a multi-line comment, you can use a triple quote. And you can also do the same thing, but you can use the single quote. Oh, there we go. You can use the single quote, which is nice because, for example, if you want to include a quote in your comment, you can use the double quote here. So the cat says hello to you. So basically, it's a nice little feature. Anyways, that's the 3 different ways you can comment. I suggest commenting your code. Obviously, you want to be careful of over-commenting, but that's pretty rare. Let's go ahead and talk about Python data types. The most basic type is the integer. What's cool about Python 3 is there's no limit to how long an integer can be as long as your computer can hold it in memory. So we can do this. As you can see, we ran this and we got the number 1. Alternatively, we could do just basically as big a number as our memory allows us to hold. And there it is. And if we did, for example, one very, 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 very large number plus 1, we'd get the expected solution. So if you have a number without anything before it and with no decimals in it, Python interprets it as an integer. 10. So that's how addition works. Pretty straightforward, and it's nice because you have unlimited memory. And any number without a decimal point is interpreted as an int. So we've got, 10. And then boom, there's an int in decimal format, or with base 10. But we can work in other bases. For example, if we prepend a 0b to the number 10, we get the number 2. Similarly, we can prepend 0 O for octal and 0x for hexadecimal. Before I run this code, let's go ahead and take a guess as to what this last line is going to print out. Okay, so let's go ahead and run the code. And as you can see, the last line prints out the number 16. That's because x stands for hexadecimal, and the integer 16 is represented as 10 in hexadecimal. In addition to integers, Python allows us to work with floats. So for example, if we look at the number 4.7, that's a nice little float. And we can look at its type. It's 4.7, boom. And it's of the class float. We can also represent floats in scientific notation by saying 4.1 E1, and that should be 41. Yep. And if we say 4.1 E negative 1, that's 0.41. Unlike integers, there is a limit to how large floating point numbers can get. For example, if we look at 1.79 E308, and then if we look at 1.8 E308, we see that we get 1.79 E308, but then anything larger than that is considered infinity. Now this is a very, very large number, right? It's 1.79 followed by 306 zeros. If you need to do computation with numbers that large, I'm sorry, I can't help you, but chances are you won't need to, right? Apparently, in order to represent the diameter of the universe, you only need, in order to represent the circumference of the universe, to the accuracy of one molecule, you apparently only need like 50 digits, maybe I think 40 digits of pi. So you won't need 308 significant figures. On the flip side, if we look at the number 5e negative 324, we should always print that. And if we look at, so this goes the other way. There is a limit to how small of a number Python can represent, and as you can see, that's 5 times 10 to the negative 324th. Anything smaller in magnitude than that turns into 0. And if we do negative, it should still play nice. Yep. So that's as accurate as we can get. Again, that's incredibly precise. These are significant figures that you won't need in any engineering capacity. One thing that's great about Python is that it includes complex numbers automatically. So if we do 2.0 plus 3.1j, oh, right. It automatically recognizes that and it doesn't have any problem. Print type. There we go. And boom, it's a complex number. I think that's just really useful. We can use an int there, and it's fine. But it's so incredibly useful that that's already built in, especially, and that's in Python 3.7. This is another reason we want to use Python 3 instead of Python 2. Lastly, there are strings, which you've already seen when we printed our hello world. Let's keep using numbers. Our hello world program. Right? So this is a string. It's not the number 1.7. See? And we can use double quotes or we can use single quotes to represent a string. They have to be consistent, right? One thing you'll notice, these parentheses here are black. If I use the double quote, they turn green because this is considered part of the string. We haven't closed the string yet, no matter whether this single quote exists or not. And if I hit F5, we're going to get an end of line error because we never closed the string. So let's go ahead and close it, and then we'll close that, and boom. It's just a string again, but now it's kind of a weird string, right? Again, a string can be as long as you want. It's just the limit is just your computer's memory. You can have empty strings. So let's see. I'm just going to work in the console. See, empty string. In addition to empty strings and very long strings, you should be familiar with escape characters. So for example, if for whatever reason I didn't want to use single quotes at all, no single quotes allowed, but I did want to have a quote, I could use the backslash and double quote, and that would automatically include the double quote there. We can also use the new line character, right? So that messes up because I didn't tell it to print. And if I do print, there, it'll insert a new line. And there's a lot of other escape characters you should be familiar with. They'll come up as we work, and I'll introduce them as we need them. You can also include a backslash. So let's see, print. You can go left or right. So that's fine, but let's say we wanted to shorten that out. Instead of saying or, we want to use a backslash. Uh-oh, see? So we have that backslash, which indicates an escape character, and we said R is an escape character, and it just sort of messes things up. So instead, we are going to use a double backslash, and there we go. It's the backslash can be represented using the escape character backslash. There are lots of other ones. Go ahead and get familiar with them as you need them. Let's see, there's backslash n is important, backslash r is useful, backslash t inputs tabs, that's another useful one. And lastly, one thing I like to use when I'm referencing files is So we can go to C\temp, and so since we have a backslash, we'll need a double backslash there, and that's fine. Alternatively, if you have a very long path, let's say it's, and then you like copy it from Explorer or something, it'd be like ctemp folder 1, folder 2, you know, that's just annoying to have to go through and insert backslashes through all of them. And you also might be inputting strings from people and not know what's coming. So anyways, you can just put an R before your before the quotes, and that's what's known as a raw string, and it'll interpret it without any escape characters. So if I said, for example, put a tab here, and \t here, if I did it without the R escape character, we'd have a nice little space there where the tab belongs, but if I put an R there, it's just interpreted as a raw string. Another data type is the Boolean. That's a capital true or capital false, not lowercase false or true. That just gets messed up. And that would be a Boolean. Nice and simple. So yeah, Boolean's pretty straightforward. You should be familiar with type conversions. So if I wanted to say int 1, that converts it to the number 1, and then this should mess it up, right? So you can't give it decimals if you want it to be an int. So let's do float 1, 1.0, 1.0, right? 1. Well, here, that's cheating, right? Float 1, float 1.0, right? Just gives us the nice little float representation of that string. You can convert things to Boolean. You can convert things to complex. I really enjoy that Python has the complex functionality in there. One thing that's cool about Python is that it will convert a lot of types for you automatically. So you'll see I started with a float plus a float times j, and it gave me this nice little complex. Or excuse me, I started with an int plus an int j, and it gave me a complex, and then I added a float to it, and it automatically converted that 1 to a 1.4, or converted to a 1.0 and then added 0.4. So that's the basics of Python data types. Let's move on to Python variables. So you should be comfortable now with Python data types. Let's do a brief review of variables in Python. So to assign a variable, you just pick a variable name, variable 1, and then I'll assign that as the number 1. And then if we do print variable 1, we should get a 1. There we go. So that's honestly variables in a nutshell. Pretty straightforward, right? You can add variables. So if I do variable 1, then I do variable 2 as 2, variable 1 plus variable 2, it should give me the number 3. Great. Now if I convert that to a float, there shouldn't be any problem. Now let's try. So that's nice because Python automatically converts types unless we give it a string. You should be careful with that because you can't automatically convert things to you can't automatically convert from strings. So if I say float variable 2, that should give me 3.0, just like we planned. So let's move on to review control flow. And this is the part of programming that gets me really excited because we're not just crunching numbers, the computer is making decisions for us, and that's where the real power of computer programming comes in. Let's start with the if statement, and that's just evaluating a Boolean. So we're going to start by saying number equals 10, oops, variable 1 set equal to 10, and then we're going to evaluate if variable 1 is less than 100, then we're going to print v1 less than 100. And then boom, there it is. We have our print statement. Now, so a few things to note here, right? Your if structure just has something that evaluates to a Boolean. So I can just put that in there and it'll evaluate to a Boolean. Anything in here, or anything that returns true or false, you can throw that right after the if. And then you have to terminate your statement with a colon, and then you can actually just do it on one line, and there we go. But if you have something more complicated in your control structure, then you insert a new line, and then you insert 1, 2, 3. You insert as many spaces as you want. And that's another thing that's cool about Python. You don't need all those darn curly brackets, right? It's just white space is a control structure. So anyways, that's a basic if statement. If you want the program to do something differently for when variable 1 is greater than or equal to 100, then you use else, and that's print v1 greater than v1 greater than 100. And if we hit F5, we still get v1 less than 100 unless we do that. And I should set this equal to. And then we see v1 is greater than or equal to 100. The next control structure is the while statement. While, well, let's start with that. I equals 0. While I less than 10, print I equals I plus 1. Then boom, we just have a nice little count up from 0 to 9. One thing you guys might be tempted to try is I plus plus, and if we do that, we get an error. The plus plus symbol is really nice and convenient in a lot of languages. It's not supported in Python. So we'll say I plus 1, I equals I plus 1. I plus 1. Whew, that was rough. And now what's cool is, there we go. So we have our little count up. We can do I equals I minus 1, set I equal to 10, while I greater than 0, we can do a little countdown, and then we'll have it say print. Great, so this is a nice little countdown timer. You guys are now aerospace engineers and can launch your own rockets. Similar to the while loop is the for loop. So we'll say, for I in range 0 to 5, print I. And boom. So we have a nice little count up again. What happens if we switch these around? I don't know. I've actually never tried that. Well, I probably tried it. Okay, so this is interesting, right? The range structure, the range iterator counts upwards always. So we should do 0, 5. What happens if we do range 5, 0, -1? Uh-oh. I'm just playing around now. I really should do this off camera. X for X in. There we go. Okay, so you can have a countdown, but you have to specify that. So for range in 10 to 0, and we count by -1, boom, we have our little countdown timer. And we could probably count by -2s, right? So that's kind of neat. Range is very useful when you want to iterate through something. One thing you might need to do is short circuit your program. So for I in range 10, 0, 1. So let's say we're doing a countdown and we really don't like the number 3, right? Print I. Great, no problem. But we don't like the number 3 for some reason. If I equals 3, then we're going to print. Oh no, 3 showed up. And then we're going to break. And that is going to exit out of this. So we'll, just to show that we finished the loop, done, exclamation point. There we go. So, oops. oh, 0 to 10. Okay, so we 0, 1, 2, 3. Oh no, 3 showed up, so we break out of it. If for some reason we want to continue running and we just don't want to run for this particular example, we can use continue instead of break. So you'll see we have 0, 1, 2, and then 3 showed up, so we're not printing 3. We're just going to go back to the top of the loop, and then we're going to keep working. So that's the continue statement. So in addition to variables, you might want to use data structures in Python. For example, we have the list structure, which is just a nice ordered collection of objects. So we can input anything we want as long as we use these square brackets. So we can mix types, so 1.0, and we can even include strings. And that is a list. Lists are cool because you can add lists together to 2.0 and 2. Oops. There we go. You can add lists together and it'll automatically, unpack them and combine them as you need. You can iterate through lists. So if you've got a for structure, we'll say for item in, let's go something simple. There we go. We're going to print. We can iterate through that and just work with it as a variable. Print type. There we go. We can iterate through it nicely and get its type. We can work with it. We can add stuff to it. So we say item plus 1. So we should get the number 2 over and over. But if we run this, we'll see that item in the last iteration is a string, and we can't add those natively. So you see we got our 2.0, and then we failed. So if we convert this to a float every time, boom, now we have our 2's showing up every time. If for some reason you don't want an ordered list, you can use a tuple, and that's just with parentheses. It's nice and useful for different things. Well, let's just 2. There we go. It comes in handy. You want to be aware of it. One thing that's cool about it is that you can use the command. Let's say if we've got 1, 1, 2, 3, 4, 1, 1, right? If we've got this list, you can get rid of duplicates using the set command, and boom, now you have a set. So set is another type of data structure that you should be familiar with. And sets are cool because you can just use basic old set theory and do some simple operations. So if we do set, there we go. So set 1 plus 2 plus 3, and then we'll do set again, and then, oops. There we go. So you can do intersections, or you can do set subtraction, basically saying take anything out that's already there. And if we get rid of this 4, then we should get to the number 4. Yeah, sets are nice. They let you do kind of fun stuff. Or with any of these data structures, we can use the keyword in. And in is really nice because let's say we've got this list 1, 1, 2, 3, 4, 4. If I say 4 in that list, that comes out as true. And if I do this, oops. If I use the float for in, that comes out as true because it compares it. And then if I do the number 4, it comes out as false. So that's just a very useful feature, the word in. So one thing about lists, if we've got the list A equals 1, 2, 3, 4, 5, we can reference individual elements of A starting from 0 through, well, let's try 5, and that should fail, and 4 should work. One thing that's kind of cool is we can use negative indexing. So A at -1 is equal to 5. We can get the length of A, and that's also 5. The last data structure I want to cover is the dict, or the dictionary, which is just a set of key value pairs. I can define a dictionary as simple as using 2 curly brackets. If I check the type of that, boom, it's a dictionary. It's not very useful, but if we include key values, then it becomes really useful. So we can say key 1, we set its value equal to 10, and then we say key 2, we set its value equal to 20. Well, yeah, 10.0. And then if we hit, we can reference it using brackets. If key 1. Oops. I always forget my print statements. There we go. So that's how you reference a dictionary. Dictionaries are really powerful. If I do A of key 2, and you can use almost any type that we've covered as a key, any of the simple types. I don't think you can use lists as keys, but you can use them as values, which is really nice. So you could say A equals, and boom, boom, 1, 2, 3. Oh, here we go. We'll do 1, 3, 5. These are odd numbers, and then even numbers as 2, 4, 6. A at odd. Oops. A at. I have fat fingers. It's very frustrating. Odd. And then you get 1, 3, 5. What's cool about all these data structures that we've covered is that you can iterate through them. For example, I still have A as a dictionary. Great. Now that's a little complicated. I'm going to say B is equal to 1, 2, 3, 4. Well, 1, 2, 3. And if I say for element in B, print element, it will go ahead and run that. And then, well, let's be a little bit more thorough. There we go. And then if we say that A, I'm being lazy here. So we recreate this dictionary, and we'll say A is equal to this dictionary here. And we can say for element in A, print A at element. That should do it. So what we're doing is we're saying, well, let's print element first. There we go. So we get the key, and then we get the value when we're iterating through a dictionary. So yeah, iterating through stuff in Python is really nice and simple. It takes care of a lot of that back-end structure, that that boring stuff that nobody wants to worry about. Let's go ahead and conclude this lesson with a quick example where we calculate the trajectory of a particle.